Welcome to clickmyproject.com. Title of our product is a 42-170 MHz PLL-based pulse width modulation driver using 2, 3 and 5 level Class D power amplifier in 130 nm CMOS technology. Abstract of our product is a high speed driver that provides a pulse width modulated output while using a Class D power amplifier is described. A PLL based architecture is employed which eliminates the requirement for a precise ramp or triangular signal generator and a high speed comparator, which are typically used in pulse width modulation generation. Multi-level signaling is proposed to enhance back-off as well as peak efficiency, which is critical for signals with high peak to average power ratio. A differential flooded power with pulse width modulation scheme is introduced to active high linear interpolations. 3-level operation is achieved without the requirement for additional supply source or single link path, which 5-level operation is achieved with an additional supply source by sync path compared with the 2-level operations. The pulse width modulation driver has been implemented in a 130 nm CMOS process and can operate with a switching frequency of 40 to 170 MHz. Performance has also been verified for 2 and 3 level power amplifier with a high PAPR signal with 500 kHz bandwidth. While intended as a general purpose amplifier, the approach is well suited for applications such as power line communications. Now we are going to discuss about the flow diagram of our product. We are using different 4 modules to implement our product. They are BID compensator, non-overlapping operations, level shifter and driver, and then multi-level Class D power amplifier. BID compensator contain some capacitors and resistors and then power amplifier. The output of the power amplifier is directly applied into the non-overlapping operation. In this non-overlapping operation contain some components and some blocks. They are voltage controlled oscillator, phase detector and a multi-mode controller. These all are the blocks are running under the non-overlapping operations. These non-overlapping operation blocks are directly applied into the level shifter and driver. In this level shifter, shift the level into next level for using this driver option. This shifted level is directly applied into the multi-level Class D power amplifier. In this multi-level Class D power amplifier can be implemented by using a different NAND gate and OR gate operations. This output of a OR gate is directly applied into the NAND gate. This NAND gate will produce the final output waveform via some capacitors and inductors. Series resistor, capacitor and inductors are function on the back end of our product. This multi-level Class D power amplifier is directly applied into this back end inductor. They will produce the final output waveform of our product. Now we are going to discuss about the running procedure of our product. In our product we are using a LT Spice 4 tool to implement our product. First, we create a new schematic using this file option. Click File to create a new schematic. Our schematic can be untitled. In order to save this schematic, using the Save As option, to save as a desired name, close this design. Our product can be implemented as a name as a class D power amplifier. This is our design. In order to run this design using this save and run option, click run to run this product. This is an output waveform plot of our product. In order to add any plot, using this plot setting option, to add plot plane to create any add in this waveform side. Now we are going to see about the input signal of our product. After running this design, we can get a probe symbol in order to obtain the output waveform. This is a positive input of a PID compensator. Now we see the negative input of our PID compensator. In order to select a ground page to obtain the PID compensator negative voltage. This is a negative of the PID compensator. In order to increasing the positive edge of the compensator, the negative edge of the compensator will be triggered using this manner. This output waveform can be directly applied into the non-overlapping operations. Now we are going to see the non-overlapping operation output waveform. This is a non-overlapping output waveform. This non-overlapping output waveform directly applied into the level shifter and drivers. Now we are going to see the level shifter output waveform. This is an output waveform of a level shifter and then the divider. This output waveform can be directly applied into the back end of our product. Back end contain different inductor, resistor and capacitors. In order to obtain the final output waveform, we can obtain this probe into the capacitor block. This is a final output waveform of our product. This waveform contains different times between the 0 to 5.0 picoseconds. In order to get the final power of our product, using this alt symbol to get the final power of our product. This is a final power of our product. Our product contains 0 milliwatts to 240 microwatts. Thank you for watching this video.